Hollingsworth Management Services Machine Guarding Safety Training. Introduction. Crushed hands and arms, severed fingers, blindness. The list of possible machinery-related injuries is as long as it is horrifying. Safeguards are essential for protecting workers from needless and preventable injuries. A good rule to remember is any machine part, function, or process which may cause injury must be safeguarded. Where the operation of the machine can injure the operator or other workers, the hazard must be controlled or eliminated. Causes of machine accidents: reaching in to clear equipment, not using lockout tagout, unauthorized persons doing maintenance or using the machines, missing or loose machine guards. Where mechanical hazards occur: point of operation, all parts of the machine which move, such as flywheels, pulleys, belts, couplings, chains, cranks, gears, etc., feed mechanisms and auxiliary parts of the machine, in running nip points. Point of operation: that point where work is performed on the material, such as cutting, shaping, boring, or forming of stock, must be guarded. And this identifies the point of operation for a drill press, and this identifies the point of operation for a spot welder. Point of operation: power press with automatic feed. There's the transparent enclosure here, the danger zone, which is the point of operation here. In-running nip points. In-running nip point hazards are caused by the rotating parts on machinery. There are three main types of in-running nips. Parts can rotate in opposite directions while their axes are parallel to each other. These parts may be in contact, producing a nip point, or in close proximity to each other, where the stock fed between the rolls produces the nip points. This danger is common on machinery with intermeshing gears and rotating cylinders. Another type of nip point is created between rotating and tangentially moving parts. For example, a chain and a sprocket, a rack and a pinion, or a point of contact between a power transmission belt and its pulley. Nip points can also occur between rotating and fixed parts, which create a shearing, crushing, or abrading action. For example, spoked hand wheels or flywheels, screw conveyors, or the peripheral of the abrasion wheel on an incorrectly adjusted work rest. In-running nip points. This is a rotating cylinders where the nip point is here, chain and sprocket, nip point in here, belt and pulley, nip points here, and then rack and pinion nip points on either side. In-running nip points, chain and sprocket, again, nip points right here, and then here, depending on the direction of the chain. Rotating parts, again, different types. The burr here, rotating around here. Cut, entanglement on the sprockets. In-running nip points, rotating and fixed parts. Identify nip points here, one here on the wheel, nip points along here, and then on a pedestal grinder, the nip point is in here between the work rest and the abrasive wheel. In-running nip points continued. A common hazard encountered in a conveyor system is the in-running nip hazard. This hazard will typically occur between the belt and the head pulley, or the belt and the return pulley. As seen in the anatomy illustration on the next slide, these pulleys are found at the ends of the conveyors and are often referred to as rollers by the layperson. The various pulleys found along the underside of the conveyor can also present in-running nip hazards. In-running nip points, autonomy of a belt conveyor. You have a transmission which is guarded here. We have unguarded nip point here. And then the trail pulley, and then the underside, there could be some nip points. In-running nip points conveyor system. Again, rotating shaft entanglement hazard here, rotating shaft, and then the nip point in between the belt and the rotating shaft there. In-running nip points conveyor system. This is a chain-driven live roller conveyor. The nip points along the chain and the rollers here. You have roller nip points in here, in between each roller. There's a fixed guard on the nip points within there, and then another guard over here. Requirements for safeguards: prevent contact, prevent worker's body or clothing from contacting hazardous moving parts. Secure, firmly secured to machine and not easily removed. Protect from falling objects, ensure that no objects can fall into moving parts. Create no new hazard, must not have shear points, jagged edges, or unfinished surfaces. Create no interference, must not prevent worker from performing the job safely. Allow safe lubrication. If possible, be able to lubricate the machine without removing the safeguard. OSHA guarding requirements, part 1. This comes from the machine guarding standard. A point of operation guard or device shall be as prescribed in a specific standard, or in the absence of a specific standard, shall be designed and constructed when required to prevent the machine operator exposed to the hazard from having any part of his or her body in hazardous area during the operation cycle. When an employer is exposed to a hazard created by a pinch point other than the point of operation, the hazard shall be guarded, or the employee otherwise protected. Methods of machine safeguarding. These give you the different types and examples of each type. First type is guards, which include fixed, interlocked, adjustable, self-adjusting. The next type are devices, which include presence sensing, pullback, restraint, safety control, trap wire, cable, two-hand control, etc., and gates. There are location and distance. There are feeding and injection methods, which include automatic and or semi-automatic feed and injection, and robots. And then there are miscellaneous aids, which include awareness barrier, protective shields, hand feeding tools. Fixed guard. It provides a barrier. It's a permanent part of the machine and preferable to all other types of guards. And here is an example of a fixed guard enclosing belt and pulley. Another example of a fixed guard on a power press. There's the transparent inlet on the front panel. The stock goes through here, and this is the guard that covers the danger zone. Another example of a fixed guard protecting a belt here and another belt here. Interlocking guards. When this type of guard is opened or removed, the tripping mechanism and or power automatically shuts off or disengages, and the machine cannot cycle or be started until the guard is back in place. And here is an example of the door opening on a CNC type lathe or machine, which would stop the process. Another example of an interlocking guard, and here is the trip wire. If this is tripped or pulled, then the machine would stop. Adjustable guard provides a barrier which may be adjusted to facilitate a variety of production operations. Adjustable guards are useful because they allow flexibility in accommodating various sizes of stock, but because they require adjusting, they are subject to human error. And here is a bandsaw. This right here is the adjustable guard, which can be moved up and down. Again, another example of adjustable guard. This is on a horizontal bandsaw. The guard is here, and it can be slid up and down to protect the blade. Self-adjusting guard provides a barrier which moves according to the size of the stock entering the danger zone. Self-adjusting guards avoid the potential for human error associated with the guard. And here is the guard which adjusts when the stock is pushed through. Another example of self-adjusting guard. Here is the guard. Push the stock through, the guard slides out of the way. Pullback devices utilizes a series of cables attached to the operator's hand, wrist, and/or arms, primarily used on machine with stroking action, allows access to the point of operation when the slide arm is up, withdraws hands when the slide arm begins to descend. And this here is the pullback device on the operator's arm. Pullback device continued, hands in die, feeding, point of operation exposed, pullback device attached and properly adjusted, die closed, hands withdrawn from point of operation by pullback device. So pullback device is on, putting product in or part in. Once it cycles down, these pull the operator's hands out of the point of operation to protect them. Restraint device uses cable or strap attached to the operator's hands and a fixed point. Must be adjusted to let the operator's hands travel within a predetermined safe area. Hand feeding tools are often necessary if operator involves placing material in danger zone. And these are devices strapped to the operator's hands. It only allows them to get so close to the point of operation. Two-hand control requires constant concurrent pressure to activate the machine. The operator's hands are required to be at a safe location on the control buttons and at a safe distance from the danger area while the machine completes its closing cycle. Here are the two hand palm buttons or controls. You got to push these at the same time for the machine to operate. Protective shields. These do not give complete protection from the machine hazards, but they do provide some protection from fine particles, splashing cutting oils, and coolants. And this is a shield on a drill press. This is the shield on a lathe. Holding tools used to place and remove stock in the danger area. Not to be used instead of other machine safeguards, was add a supplement. So you need other safeguards plus these, and these are different types of tools which would you use to put a piece of stock or material into a point of operation or danger zone. Machine safety responsibilities. Responsibilities for management. Ensure all machinery is properly guarded. Supervisor's responsibility. Train employees on specific guard rules in their areas. ensure machine guards remain in place and are functional, immediately correct machine guard deficiencies, employees' responsibilities, do not remove guards unless machine is locked and tagged out, report machine guard problems to the supervisor immediately, do not operate equipment unless guards are in place. This just shows you various types of machine guarding. There are rollers and the point of operation inside here. We have a warning sign. We have protecting belts, pulleys, gears here. Again, the warning sign, stay away from when the machine is in operation. Summary. Safeguards are essential for protecting workers from needless and preventable machine-related injuries. The point of operation, as well as all parts of the machine that move while the machine is working, must be safeguarded. And then this ends the presentation portion of the safety training. There will be a 10-question quiz. Quiz. First question to the quiz. Causes of machine accidents include A, reaching in to clear equipment, B, not using lockout tagout, C, missing or loose machine guards, D, all of the above. Question 2. Point of operation is that point where work is performed on the material, such as cutting, shaping, boring, or forming of stock, and it must not be guarded. A, true, B, false. Question 3. In-running nip point hazards are caused by the rotating parts on machinery. A, true, B, false. Question 4. The various pulleys found along the underside of the conveyor can also prevent in-running nip hazards. A, true, B, false. Question 5. The OSHA Guarding Requirement Part 1 states, when an employee is exposed to a hazard created by a pinch point other than the point of operation, the hazard shall not be guarded or the employee otherwise not protected. A, true, B, false. Question 6. Blank is an example of the method of safeguarding a machine by using a guard. A, robots, B, presence sensing, C, interlocked, D, protective shields. Question 7. The picture below illustrates an example of a blank guard. A, adjustable, B, fixed, C, interlocked, D, self-adjusting. And it's these two guards here that are circled. What are those examples of? Question 8. The picture below illustrates an example of a blank guard. A, adjustable, B, fixed, C, interlocked, D, self-adjusting. And again, this is the guard they're referencing. They want to know what type of guard that is. Question 9. Two-hand controls require the operator's hands to be at a safe location on control buttons and at a safe distance from the danger area while the machine completes its closing cycle. A, true, B, false. And the final question, number 10, machine safety employee responsibilities include A, not removing guards unless machine is locked and tagged. B, reporting machine guarding problems to the supervisor immediately. C, not operating equipment unless guards are in place. D, all of the above. This completes the quiz portion of the presentation.